Hello everyone, welcome back to Linkside 201. Today we are still going to talk about morphology, but this is the last lecture of morphology. Today we are going to talk about allomorphs and morphological analysis. Okay. First of all, let's talk about morphemes and allomorphs. The definition of allomorph. An allomorph is a variant of a morpheme whose sound changes according to its environment. So actually, allomorph is very similar to allophones. Do you remember what allophone is? So here's an example of an allophone. Okay, so P can be realized. This P sound can be realized as an unaspirated P or a P with aspiration. So, for example, in speak, this P is realized as an unaspirated version. However, in peak, this P is realized as an P with an aspiration. So P can be realized as these two phones. These two phones are called allophones. A morpheme has a similar alternation. Here's an example. So we have the plural morpheme in English. And actually we have three variants of this plural morpheme. When we have a voiceless sound at the end of the root, we got s. If we have a voiced sound at the end of the root, then we got z, dogs, right? And if we have this sound like s, then we got kisses, is, right? So actually, s, s, z, is are allomorphs of the same morpheme, which is the plural morpheme. Here is another example of allomorphs. The English past tense morpheme has three realizations. We have t, d, and ut, right? When the past tense morpheme follows a voiceless sound, we got t. When it follows a voiced sound, we got the hugged, right? And if it follows with a alveolar sound, alveolar stop, then we got it, like waited, hugged, and walked, right? So the and are allomorphs of the same morpheme. This time the same morpheme, the morpheme is the English past tense. Okay, now we can try to analyze the plural morpheme in English. We can try to derive the three alternations, the three allomorphs of the plural morpheme. Okay, remember that when we try to derive the allophones in phonology, we were using formal rules, right? We have the basic form, it becomes some predictable form in a specific environment. For this morphological analysis, we are going to use a similar rule. Okay, we have basic form become some other form in some environment. So actually we have three guys to be derived, right? So we have basic form becomes S. The same basic form becomes Z. The same one becomes is in different environments. Okay. Actually, there are two questions right away to ask when we try to do this analysis. The first one is, what is the most plausible basic form? And what is the environment? Actually, these two questions are related. So for the basic form, we got three candidates here. It could be this one, this one, this one, or some other guys. But we can try to choose the first one. The first hypothesis is that the basic form is S. Okay. Then we can derive cats without a problem. It's just no alternation. Becomes no changes. Okay. And how do we account for this alternation as in dog Z? We got Z, right? So actually, to account for this, we have to have a voicing rule, which change a voiceless sound into a voiced sound. A voicing rule can be like this. So a voiceless sound minus voiced become plus voiced. In the environment like this, when he is following a voiced sound, right? For example, S becomes Z when he follows a G sound, as in dogs, right? So we can account for this alternation. However, this is not the end of the story. We still need to account for kisses. We have an extra vowel here. S becomes is. What's going on here? Actually, we will propose a parenthesis rule. So it's also called a insertion process. Okay, a insertion process. Sometimes we use a parenthesis to refer to insertion. So a parenthesis rule looks like this. So we have an empty set symbol, which means nothing, becomes a in the environment of following a strident and preceding the plural morpheme. Here I'm introducing a new concept, a new notion, strident. Strident is a class of sounds which include these guys. Okay. So the application is like we have S sound and then we have Z sound, and in between we insert a vowel. Okay. Again, we are assuming that the basic form is S. Okay, and we have two rules, voicing rule and a parenthesis rule. And actually, if we have more than one rules, then we have to think about the rule ordering. So actually, we have two possible orderings, right? We can try this first. The parenthesis rule precedes voicing rule. Then we got this table here. And actually, this is the right ordering. And this ordering is called the feeding order. Okay, we are going to talk about this in a minute. So we have three words to derive, right? And we have the same underlying form, the basic form. And first we apply the parenthesis rule, and this is not the environment for appendices, so we have non-applicable and a, and the same for g and s and a. And for the last one, kisses, this is a strident and we have s, right? So this is the right environment for the appendices to apply. So we have a insertion of the I sound. Okay. And for voicing, this is not the environment for voicing, right? Because we need the target for a voicing rule is the environment for the voicing rule must be the environment must be following a voiced sound. Here, t is a voiceless sound, so voicing rule does not apply. Here we have the right environment, right? Because g is a voiced sound, so the voicing rule applies to this one. S becomes z, right? And here we have a similar situation. We have this vowel. This vowel is a voiced sound, right? So the voicing rule applies as well. S becomes z. And we got a final output. Cats, dogs, kisses. We have a correct analysis. Now we can go back to talk about the feeding order. What do we mean by feeding order? When we have a rule, the rule 1 creates the environment for rule 2 to apply, and we have a feeding order. So if we just have kisses, we are not going to have the voicing process because the first guy, this sound is not is voiceless. So we could end up with similar to this one, voiceless. With voiceless does not trigger the voicing process. However, if we have the first rule, we have the vowel insertion rule, then the environment for the voicing is satisfied. So the voicing rule will apply because of this vowel insertion. So we have a feeding order. The first rule, the vowel insertion creates the environment for the voicing process to occur. So this two ordering is called feeding order. Okay. Now we can consider the alternative order, but this is the wrong order. If we have the voicing rule precedes the vowel insertion rule, what do we have? Okay, the first two guys, we don't have any problem for. Actually, we can still derive the right form. However, when we have kisses, what do we got here? So when we try to apply the voicing rule, this is not the right environment for voicing rule because we have a voiceless sound preceding the target, right? And then we have the vowel insertion rule. It applies because this is the right environment. And then we have the final output, but this is not the desired output. I put a star to show that this is a wrong output. Okay. And this order is called counter-feeding order because it's exactly the opposite order of the feeding order. Okay. Okay, now we can try another hypothesis as well, assuming that the basic form is z instead of s. We can do the analysis with this assumption as well. So for example, for dogs, we have this and it becomes dogs. there's no alternation at all, z becomes z. And to account for, then we have to account for this alternation, cats, then we have a z becomes s, right? Then we have to come up with a divorcing rule because we want to change z into s, right? So the rule can be look like this: plus voiced becomes voiceless, voiced becomes voiceless sound when it follows a voiceless sound. Okay, so for in this case, z becomes when it follows a voiceless t sound, right? Then we can derive these cats. And the same vowel insertion rule applies to here as well, because we want to account for kisses. And for this one, we have the same rule actually. Actually, we have the same rule. Okay, now we can, again, we have more than one rules, right? We have to think about the rule ordering. So again, we have the vowel insertion precedes divorcing. This is the right ordering. Okay, I'll show you why this is the case. So again, we have three words to derive. The vowel insertion rule does not apply to cats because this is not the right environment. It does not apply to dogs as well because g is not a triggering environment for the vowel insertion. However, for this one, we have the strident, right? S sound is one of the strident, and we have z sound. In between, we should insert a vowel. Okay, now we derive kisses. Okay, and then we have the divorcing rule. Divorcing rule apply for this one because this is the right environment. With minus voiced sound, we have t, right? Then we z sound becomes s. And the divorcing rule does not apply to dogs because this is not the right environment. We need a minus voiced sound for the triggering environment. G is a voiced sound. Okay. Yeah, and here the vowel, the inserted vowel is a voiced sound. It is not the right environment for the voicing rule to apply because this is a plus voiced sound. We need a minus voiced sound. So again, it's not applicable. And then we have the final output. Everything is good, right? Okay, now let's try the wrong order. If we have the voicing rule precedes insertion rule, then we have a wrong output. For cats and dogs, the rule order does not cause any problem. But for kisses, we have a problem here. So if we have divorcing rule first, the divorcing rule would apply here because this is the right environment for the divorcing rule to apply. We have a voiceless sound and we have z, the target. Then we have the divorcing process. Z becomes s. Then the vowel insertion will apply as well. Then we got kisses. And then we have the wrong output. And yeah, okay. Yeah, I forget to tell you about this bleeding order. So it's like the opposite of feeding order. So for bleeding order, the first rule will destroy the environment for the second rule to apply. So here, the vowel insertion will destroy the environment for voicing rule to apply, right? Because originally we have a voiceless sound. This sound will trigger the devoicing rule. However, if we have the vowel insertion, then the environment is destroyed. Okay. And for this wrong order case, it's the opposite order of the bleeding order, so it's called counter bleeding order. Okay. Okay, we just show a rule based approach to do the allomorph analysis. This rule-based approach is also known as SPE approach. SPE stands for the sound pattern of English. This is like the old style of doing morphological analysis. The most updated and most popular theory nowadays is called optimality theory, but we are not going to talk about optimality theory here. It's also known as OT. Yeah. So the derivation looks like this. We got the input here, and we have some candidates, and we have some constraints which would evaluate the candidates, and then among all the candidates, we pick up the most harmonic one. This is the way for OT to derive the output. For this, we have the same thing. So actually, in this table, we are assuming that the basic form is Z. Okay, the basic form is the input, and we have several candidates here, and then we have the constraints which evaluate the candidates. Okay, and if you are interested in morphology or phonology, here are some courses that you can take. In 315, Introduction to Phonology, then you can do more phonological puzzles, and also actually when you do phonological puzzles, you are doing some morphological puzzles as well. Yeah, and the other one would be, this one would be a more advanced one, but it's fun to take this thing for 1.0. This is then the end of this lecture. Also, this is the end of morphology. The following lecture, we are going to talk about syntax. And remember to finish the in-class exercise. Thank you. Bye bye. See you next time.